So in this session, we'll discuss the electrolysis of aqueous dilute solutions. Dilute solution means they contain more water. So when we are doing electrolysis of aqueous solution, the aqueous solutions are divided into two categories. One is called concentrated. Another one is known as dilute. The concentrated means they contain more salt and they have less water. And dilute means opposite, they have less salt and they have more water. So what will be the difference? The rule is the same for positive ion. What is the rule for positive ion? We will check reactivity, and always the less reactive will discharge or will move towards cathode. And for negative ion, we will always check the amount. The ion which is more will move towards the anode, except three ions. These three ions does never move: sulfate, which is SO4, nitrate, which is NO3, and carbonate, CO3. Even they are more in the solution, but they are not able to move. These three ions, remember, whenever even they are more, but they are not able to move because of their size. So for positive ion, we check the reactivity, and for negative ion, we'll check the amount. Now, example, we have dilute, we are doing electrolysis of dilute sodium chloride. The concentrated sodium chloride is known as brine, but not the dilute one. So when we say we are doing electrolysis of dilute sodium chloride, so it means we will have less salt, means we have less NaCl, and we are having more water, or we have more H2O. So what are the ions present? It contains sodium ion, chloride ion, and it contains H ion and OH ion. So these are the ions present in the solution. Now we are doing electrolysis, like we are passing the current. And what is the rule? For positive ion, what we do, we will check the reactivity. And for negative ion, what we will do, we will check the amount. So that is the rule for electrolysis of aqueous solutions. Now, we have electrolytic cell. Which consists of electrode made up of either platinum or graphite. So the one which is connected with the positive terminal of the battery, that's called anode, and the one which is connected with the negative terminal is known as cathode. Now what are the ions present here? So we have sodium ions, chloride ion, hydrogen ion, and hydroxide ion. There will be many ions, but I am drawing only one for each type. Now what happened for positive ion? We check the reactivity. The less reactive will move. So which one is less reactive? The electrons move from negative terminal and move towards the cathode. So both positive ions are attracted. Attraction is there for both. But which one is able to discharge? The hydrogen, because hydrogen is less reactive, so hydrogen is able to discharge. So as the hydrogen is able to discharge, what will be the half equation at cathode? So when hydrogen ions are there, they will take one electron and it will turn into hydrogen atom. When two hydrogen ions are there, they will gain two electrons and it will turn into a hydrogen molecule. So what is the observation when hydrogen molecule is there? So we'll have colorless gas, or we can also say bubbles are seen at cathode. This is what happened for the positive. For negative ion, we check the amount. So which ion is more in the solution? Is it chloride or hydroxide? Which ion is more in the solution? So it is hydroxide ion or OH ion. So both ions are attracted, even chloride is attracted, OH is also attracted, but the ion which is more, that is able to discharge, so OH ion is able to discharge. So half equation for anode. So whenever hydroxide ion is moving, when one hydroxide ion move, it will lose one electron and it produce hydrogen atom and oxygen atom. But in exam, you don't have to write for one. Actually, you have to memorize this equation. You have to learn the equation for OH. So what will be the equation for OH? This is what happened. But the overall equation for OH is you have to learn or memorize that when four hydroxide ions are there, they will lose four electrons and it will produce one oxygen molecule and it will give two water molecule. This is the fixed equation which you have to learn for hydroxide ions. Whenever hydroxide ion will move, they will give oxygen and water molecules. So what is the observation? What you will observe, because oxygen is there and oxygen is also a colorless gas, so you will say a colorless gas or bubbles are seen at anode as well. So for hydroxide, this equation is very important, and what you have to do, you have to memorize, you have to learn this equation. For others, you can write it by your understanding, but for this equation, you have to memorize. That four hydroxide ions are there, they will lose four electron and give oxygen molecule and two water molecules. And what is the observation? Yeah, this is fixed. You have to learn. Even you can memorize all the equation if you want to, but for others, for the other examples, we can write it. For example, if you are not able to memorize the other part, you can write it by yourself, use your understanding. But for this hydroxide equation, you have to memorize because it is fixed. Now what happened? So this is what happened, anode and cathode, the movement of ion is there. Now what happened to electrolyte? Electrolyte means what we are left with. As you can see, the hydrogen ion is being removed, hydroxide ion being removed. So what we are left with in an electrolyte, we are left with sodium chloride, NaCl. Is it clear? This electrolysis of dilute sodium chloride. Anyone having a question or a doubt till this point? Okay. Another example for electrolysis of dilute solution. Electrolysis of dilute KCl. So what are the ions? You dilute solution means you will have less salt and you have more water. So you have less KCl and you have more H2O, means potassium ion, chloride ion, hydrogen ion and hydroxide ion. So you have the positive ions, you have the negative ions. For positive ion, what we do for a positive ion, we check the reactivity. So the ion which is less reactive will move towards the cathode. And for negative, we check the amount. So for negative ion, what we do, we check the amount. The ion which is more in the solution will discharge at anode. Except the three sulfate, nitrates and carbonate are not able to discharge, not able to move because of their size. So the one which is connected with the positive terminal is known as anode and the other one is cathode. The ions which are present here, so we have potassium ion, chloride ion, hydrogen ion and hydroxide ion. For positive ion, we check the reactivity. Which one is less reactive here in this example, potassium or hydrogen? So when we check the reactivity, hydrogen, yeah, that's right. So hydrogen is less reactive, so hydrogen will discharge. Both are attracted, but the one which is able to discharge is hydrogen. Now what will be the equation for cathode? The equation for cathode, the hydrogen ions are there. They will take electron and turn into a hydrogen atom. But when two hydrogen ions are there, they will take two electron and form hydrogen molecule. What is the observation? The observation will be bubbles or colorless gas. What happened at anode? For anode, we check the amount, except the 3 does not move. So which one is more here? It's a dilute solution. So dilute solution means it contains more OH. So which ion is discharged at anode? Is it Cl or OH? Which ion is able to discharge? Cl or OH? So it is OH ion. The OH ion is able to move or discharge at anode. So whenever OH ions are there, they will fix equation 4E. gives one oxygen molecule and two water molecules. That's a fixed equation which you have to memorize. And what is the observation? Because oxygen is there, so what we'll observe? We'll observe bubbles or a colorless gas. Now what happened to electrolyte? Electrolyte means what we are left behind. H is being removed, OH is being removed. So what we are left with? We are left with KCl. So the electrolyte will turn into KCl only. So this is what we do or observe during electrolysis of dilute potassium chloride. Another example, if we have concentrated copper sulfate. So if we have concentrated copper sulfate solution, and we are doing electrolysis by using inert electrodes such as graphite or platinum electrodes. The one which is connected with the positive terminal is anode, the other one is the cathode. So we have a concentrated copper sulfate solution. Now, when we say concentrated copper sulfate or aqueous concentrated copper sulfate, that's the same meaning. So because it's a concentrated solution, it means it will have more salt and it is having less water. So what are the ions present? Copper ion is there because the copper sulfate, so copper ion is there, sulfate ion is there, and it contains hydrogen ion as well as hydroxide ion. So these are the ions present in the solution. For positive ion, we check the reactivity, the positive ion we check the reactivity, and for negative we check the amount. Now in the solution, as we are doing electrolysis, so the ions which are present, copper ion, sulfate ion, hydrogen ion and hydroxide ion. These are the ions present in the mixture, in the solution. For positive ion, we check the reactivity. Which is less reactive, copper or hydrogen? Which ion is less reactive? When you check the reactivity series, this is the reactivity series. You have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum. And as we go down, the reactivity is decreasing. So can you work out which is less reactive? Is it hydrogen or copper? As we go down, the reactivity is decreasing. So it is copper or Cu. So both ions are attracted, but the copper ions are able to discharge. So when we write equation, half equation for cathode, so when we write half equation for cathode, the copper ion will gain 2 electron and it will turn into copper atom. And we don't have to write for a molecule. Why? Because a copper is a metal. And whenever a metal is formed, what is the observation when metal is formed? Because metal are solid at room temperature and copper is brown in color. So the observation is brown solid formed at cathode. And there is also a second observation, because copper ion is blue in color. You have to learn these colors. Copper ion is blue in color and copper, which is solid, is brown in color. So what happened? Because the copper ion are moving, so copper ion is decreasing. The amount of copper ion in the solution is decreasing. So what is another observation? We'll see the color of the solution turn lighter or paler. Originally there are more copper ions, but as these copper ions which are blue in color, so originally due to the presence of the copper ion, the solution will be blue. Why I did not use these type of things for the previous example? Because group 1, 2 and 3, they don't have, their ions are not colored. That's why it is always a colorless solution. But in case of copper, copper ions are colored, so that's why originally the solution will be blue in color. But as the amount of copper is decreasing, the solution will turn lighter. That is also the second observation when a copper ion turn into a copper atom. Is it clear, the half equation for cathode and the observations till this point? Any doubts? The previous examples I was not using any color of the solution, because all these cases, whenever group 1 ions are there, group 1, 2 and 3, they all are colorless solution. But for copper solution, they are always blue in color due to the presence of copper ion. So as the amount of copper ion decreases, the solution will turn lighter. So brown solid is formed, brown solid is deposited at cathode. That brown solid is actually a copper metal. And what is the second observation? The solution, the color will get lighter. Is it clear till this point? The half equation for cathode and observation. Then the second part, what happened? The second thing, what happened? For negative ion, we check the amount. The ion which is more in the solution will move. So which ion is more in the solution, sulfate or hydroxide? Yeah, the copper ion changed to copper solid. So copper ion is blue in color, whereas copper solid is brown or pink in color. So the solution changes from blue, like the solution amount of copper ion is decreasing, so it will become lighter, and a brown solid is formed at cathode. When we check for negative ion, we check the amount, so sulfate is more and hydroxide is less. But if you read the last part, I said the ion, check the amount, the one which is more will move except three. Sulfate, nitrate and carbonate, even they are more, they will never move. Because of their size, they are not able to move in the solution. So even sulfate ions are more in the solution, but they are not able to move. So if they are not able to move, which ion will move? The hydroxide ion will move there. So half equation for anode. What is the half equation for anode? Because the sulfate never move, so hydroxide ion will move there. When 4 hydroxide ion will move there, they will produce oxygen and 2 water molecule. Whenever oxygen gas is there, so we say colorless gas or bubbles. So bubbles or colorless gas is observed at anode. And what happened to solution? What happened to electrolyte? As we know, copper is moved out and hydroxide is moved out. So what we are left with? We are left with hydrogen and sulfate. So what is the compound form when hydrogen ion combined with sulfate ion? So this two will come with hydrogen and one will come with sulfate. So this electrolyte contain hydrogen ion and sulfate ion. So when they combine, what is the resultant compound form? So it will be H2SO4. So the electrolyte will turn into copper, it turn into H2SO4, which is also known as sulfuric acid. So for positive ion, we check the reactivity. As copper ion is less reactive, it is discharged at cathode, and due to the formation of a copper metal, we'll observe a brown solid. The solution will get lighter, the color will get lighter. For negative ion, we check the amount. So even though, as you can see, sulfate is more and hydroxide is less, but sulfate, carbonate and nitrate never move. They're not able to move. So even it is more, it does not move. So in that case, again, OH is able to discharge. And whenever OH discharge, it gives oxygen gas. So we'll see bubbles and we'll observe a colorless or bubbles or colorless gas, that is oxygen. As the copper ion and hydroxide ion are going out, so we are left with H ion and SO4 ion. So when these ions join together, they form a compound which is known as H2SO4 or sulfuric acid. So this is the electrolysis of aqueous concentrated copper sulfate solution. It is very important. You will find in exam almost every year they are asking a question regarding this electrolysis of aqueous concentrated copper sulfate using platinum or graphite electrodes. So you should learn these observations. There will be a brown solid, the solution will get lighter, and we'll also observe bubbles of oxygen. Now when we compare, as we compare the electrolysis of molten, dilute or molten, concentrated and dilute solutions, so example, we have three solutions. One is molten, another one is dilute, and the third one is the concentrated, or the second one can be concentrated and the third one is. So on the left hand side we have molten NaCl. At the center we have concentrated NaCl, and at the last one we have dilute NaCl. So first, what are the ions present? Because the first one is a molten. So molten means there is salt only. It will have salt and there is no water. So it will have, the salt will be NaCl, Na plus and Cl minus. So when we are doing electrolysis of the molten, using the electrodes, the inert electrodes such as carbon and graphite or graphite or platinum. So only two ions are present. There is sodium ion and there is chloride ion. So we don't have to check the reactivity, as we already know there's only one positive ion, so sodium ion is there and chloride ion. So what happened at cathode? The sodium ions are attracted towards cathode and they will turn into sodium atom. And what happened at anode? The chloride ion will lose one electron, turn into chlorine atom. When two chloride ions are there, they will lose two electrons and form a chlorine molecule. So what is the observation? We'll see solid is formed, and because the chlorine gas is there, so yellowish green gas. I just write in yellowish uh, gas, but it will be yellowish green gas. And what happened to electrolyte? The electrolyte will be used up because you're not left with any sodium or chloride ion. But when we say we have concentrated, so it means salt is more and water is less. So we have more sodium ion and chloride ion, and we have less H and OH ion. So when we are doing electrolysis, I'm just drawing the electrode. So we have sodium ions are there, chloride ions are there, H plus and OH minus. Now what happened? For positive ion, we check the reactivity. So the less reactive hydrogen ion is attracted towards cathode. So what will be the equation for cathode? That hydrogen ions, they will take electron, turn into a hydrogen atom. When two hydrogen ions are there, they will take two electron and turn into a hydrogen gas. And what about anode? For negative ion, we check the amount, because we have more, it's a more salt concentrated. So Cl will move there. So when one chloride ion will move, it will lose one electron and form chlorine atom. When two chloride ions are there, they will lose two electron and form chlorine molecule. So the observation again, yellowish green gas. And because hydrogen is there, whenever you have hydrogen, so it will be a colorless gas. And what happened to electrolyte? Electrolyte means what you're left with. So hydrogen is being removed, Cl is being removed, so you're left with NaOH. So the electrolyte, it will turn up into NaOH. If you have dilute sodium chloride, so it means salt is less and you have more water. So you have sodium ion, chloride ion, H ion and OH ion. These are the ions present. These are the electrodes. We have anode and cathode, which is made up of either graphite or platinum. So the ions which are present, sodium ion is there, chloride ion is there, H ion is there, and OH ion. What happened at cathode? Because the ion which is less reactive, so again hydrogen is less reactive. So hydrogen ions attracted towards cathode and form a hydrogen atom. But if two are there, it will form a hydrogen molecule. And what happened at anode? Because OH is more, and for OH you have to learn this equation. When 4 OH ions are there, they will lose 4 electron. It will give oxygen and 2 water molecule. So what is the observation that you have to learn? Whenever hydrogen, you can say bubbles or colorless gas, and oxygen is there, you will also say bubbles or colorless gas. What happened to electrolyte? The solution, as OH is being removed and H is being removed, so you're left with NaCl, or you're left with more NaCl, or you can say it is concentrated NaCl. Is it clear the comparison between the molten, the concentrated, and aqueous solutions, their electrolysis? Any question or a doubt?